The step 7 is the mechanical testing to get a series of properties such as the film index, resilient, modulus, creep. There are 2 operational tests: moisture susceptibility and beam fatigue resistance. These tests are only for medium to very heavily trafficked road. Ideally, the mechanical properties of asphalt in situ are required for pavement design purposes. Reproduction of in situ stress conditions in the lab is difficult, so these simplified tests are introduced to indicate certain aspects of the in situ behavior. The relationships of these properties with the binder content are shown in these figures. So we can see that the testing is performed at a single trial binder content 5%. If the requirement from the specification or guideline is not met, we could plus or minus the trial binder content by 0.5% or 1% and prepare a new mix until the requirement is properly met. In previous slides, we discussed level 1 and level 2 testing. Level 3 testing is the testing for verification. It is only required for heavily trafficked road or where extra reliability in terms of routing performance is required. It has 2 parts: the check of the air voids using a gyratory compactor at 250 cycles and view tracking of the asphalt slabs. Let's look at air voids verification test first. The air voids content of a mix affects the stability and durability. Experiences indicate that asphalt mixes with air void content less than 2 to 3% are likely to be unstable and prone to rotting. This is because the binder almost totally fills the void spaces and reduces aggregate particle interlock and friction. The specification requires the mix, which has a design air void content of 5%, must have greater or equal to 3% voids at 250 cycles. With a mix, a mix with design voids of 4% would need to have greater or equal to 2% voids at 250 cycles. We could take measurement, work out the air void at 250 cycles and check if it meets the above requirement. This air void check is normally done during the level 1 testing. The view tracking test is the asphalt slab repeatedly traversed by a loaded view to correlate to road performance as shown here. It is used to measure the deformation resistance and widely accepted in a number of countries. For view tracking, normally a 300 millimeter square slab with 50 millimeter deep or 75 millimeter deep is made from the asphalt mix. The corresponding air voids of the slabs must be 5 plus 0.5% to get a characteristic value. The test is normally carried out at 60 degrees using a wheel of 50 millimeter width and 200 millimeter diameter with top load generates pressure of 700 kPa. The results are expressed in terms of view tracking rate or final tracking depth. You can watch a view tracking test demonstration through the link below. The view tracking test is stopped either when 10,000 passes have been completed or the tracking depth is greater than 15 millimeter. For the parameter of view tracking rate, it is calculated as the change in tracking depth with the number of passes over the range of 4,000 to 10,000 passes. The result could be converted and is priced as the final tracking depth after 10,000 passes. Although the tracking rate is commonly used overseas, it is not considered. The tracking depth after 10,000 passes is a more appropriate parameter to indicate the asphalt performance. Some typical tracking depths for laboratory prepared asphalt samples are shown in the table below. So if the tracking depth is 3 millimeter, it indicates superior performance. Otherwise, 14 millimeter indicates the low performance. For aggregate grading calculation, we could have a better understanding of the calculation process from the example in tutorial 6. In this table, we have 3 samples with bitumen content of 4%, 5%, and 6%. The sample weight is 1,200 grams. So for 4% bitumen content, the weight of bitumen is 48 grams, and the total weight of aggregate is 1,200 minus 48 equal to 1,152 grams. The upper and lower bound grading LE6 values are shown in the last 2 columns. The calculated grading ought to be bounded by these values. The first column is the sieve size, and the second column is the percentage of the weight retained based on grading target from Fuller and Thompson formula. Normally, the first 2 columns and the last 2 columns are given. For sample 1, firstly, we need to work out the mass retained. So using 1,200 grams times 96% or 0.96 times the values in column 2. The mass passing is the mass of the aggregate minus the retained mass from each sieve. And finally, the grading is calculated using the passing mass divided by the mass of the aggregate, 1,152 grams. We could do the same way and complete the table for different bitumen content. Next, according to the threshold of PC, PF, and PFill, we could work out the weight of coarse aggregate, fine aggregate, and filler. The percentage of bitumen is 4%, so the weight is 48 grams. If we take the PC for example, it corresponds to the retained weight for sieve size equal or greater than 4.75 millimeter. So if we go back to the previous slide, the total weight of aggregate is 1,152 grams, and the mass passing the sieve size of 4.75 millimeters sieve is 599.04 grams. So the weight of coarse aggregate is 552.96 grams. If we divide this value by the total weight of 1,200 grams, we get the PC value of 46.08 in percentage. Similarly, we could work out the PF and PFill. For the red table, we could make full use of the formulas we learned in this lecture to get all these values. All right, a summary of this lecture. The asphalt mix design process has 3 levels and 9 design steps. Level 1 testing is to obtain the volumetric properties. The level 2 testing is the mechanical testing, while level 3 testing is the verification testing. We learned how to calculate the aggregate gradation and the percentage of coarse aggregates, fine aggregates, and filler for a specific bitumen content. We also learned how to use the formulas to calculate the volumetric properties of the asphalt mix, such as AV, VMV, VFV, and a few other parameters. Finally, according to the specification or requirement like design air water content, we could determine the design bitumen content from the plots of testing results. That's the end of the lecture today. Thank you for your attention, and I hope you guys have a wonderful day. I'll see you next time.